things of that nature. About the only thing that the computer can do by itself is the camera, which is connected via USB. So to solve this problem, the Maslab staff, over a number of years, has developed what's called an ORC board. ORC here standing for Our Robotics Controller. Primarily developed by the founder of Maslab, Ed Olson, and has now evolved into quite an impressive piece of software featuring 2 FPGAs, 4 motor ports, 8 analog sensor ports, 8 digital sensor ports, and a number of other features that I don't know about. So we give team members an ORC board, an ORC pad, which is essentially lets them visualize things on the ORC board, and a small form computer, which is about, I don't know, 8 inches by 4 inches. Other than that, we give them very little other than advice and our best wishes. We then also give them raw materials and let them have at it. And the results, as you can see over the day, are quite impressive. So at this point, okay, well, so to talk a little bit more about the competition, hold on. I feel Maslab is not a cheap contest by any stretch of the imagination, so I feel obligated to thank our sponsors here at the beginning. If some of the representatives from ITA Software could stand up. So there are I've never understood this. I'm supposed to say D.E. Shaw Group, but everything I see on them says D.E. Shaw and Company, so if their representatives could stand up, please. I don't think there's a representative from the EECS department at MIT, but they very generously give us lab space. All we have to do is make sure it's clean at the end, and other than that, they've been very supportive. We certainly also have a number of other sponsors. The very coordinated Sun Microsystems is here. If they want to stand up. We also have a number of other part sensors, analog devices, designed a very nice gyroscope, which is able to give relatively accurate readings for what orientation the robot is on. Most teams have used that sensor to great effect for various things. And over the course of this competition, we really hope that you're able to learn a little bit about robotics, even if you just learned what the word robot means, or if you know what FPGA is an acronym for. Hopefully you'll get a little bit of knowledge out of this today. One thing I would also like to mention is a cautionary word. Because these things are using cameras, they're very sensitive to light changes, so please no flash photography at any point in the competition. It will severely affect many of the robots, and odds are if you're taking a picture, you like that team. I'm hoping that you like the teams. Please don't take flash photography. At this point, I'd like to invite up Team 5 for a short So you can see over there, up on one display, and we have slides over there featuring a little bit about Team 5, and you can also see a bit about the evolution of their design. So this slide features diagrams and whatnot, just so you can see kind of the evolution of the robot over time. We'll have these for each team. Also in the center, you'll be able to see an unofficial timer. Each round is limited to 5 minutes. The robot is required to stop at the end of 5 minutes and 10 seconds. If it does not, as according to our official timer, Rurik Rimani over there, then they're docked 3 points. Negative scores are not allowed. We have an unofficial timer here up on the main projector, as well as the bot client. So this is a tool that students use for debugging. You're able to send many commands over TCP/IP, I believe, and debugging images, that sort of thing. So whenever you're ready. So Erica is going to press the button, and we're going to begin. So a lot of robots are slow to start at the beginning because they're initialing the gyroscope. Are you guys doing that right now?
Yeah, we have first it goes through a warm-up stage where it the gyroscope using those cameras started to get the processing going. Just a little more like down the way. We're trying to make that as short as possible.
So, what's it? Is it going into an exploration state? What's your guys' strategy for that?
So our robot we're operating a state machine setup. That's worrisome because it looks like our camera is calibrated very well. This might not go very well. So navigation, our robot has a survey state.
It's hard to see. Oh, it just got it out.
Navigation, our robot has a survey state that'll survey its surroundings, turning around 360 degrees and 30 degree increments. And then if it doesn't see anything, it'll go into wall following. We're quite proud of our wall following algorithm because it works fairly well. It moves pretty slowly, but it was fairly accurate and easier to control.
So one thing that I think just happened with your robot that's very hard to tell, and one of the real irritating parts of robotics, is that it got jammed up on the wall right there. But it seems like there's some sort of timeout and it knows that it's stuck, which is actually very, very difficult to account for. So what do you guys, how are you guys detecting that sort of thing?
Right, so we have a bump sensor array that's surrounding the robot. That's what the sponges are. It registers when the bump sensors are hit, and it'll go ahead and evade the wall. Unfortunately, there's a delay in the bump sensor. We're not sure what causes that, but
that's it eventually.
Right. So the robot's currently looking for balls and goals. Its ball capacity is.
It has just lost a few of them. It's hard to see, but maybe it's going to recover one. So how do you deal with balls very up close against the walls? Do you have trouble with those, or?
Yeah, we actually do have lots of trouble with balls, really close to walls. Because of the way the gate is set up, it's hard to stay well. So there it sees the goal, so it's going to try to score. Obviously, it's not going to score that goal, but it doesn't have balls.
So, does it, I didn't try to score a goal initially. Are you guys keeping a rough track of how many balls you think? Are you using vision to detect that, your camera, or what's going on there?
So, what we're doing is basically assuming that if we go after a ball, then it gets the ball, and then it keeps track of how many it has. We know our ball capacity is,
Oh yeah, well the bot stalled, you should logically be stalled as well. The connection between robots and the teams is just very... So is it stalled out here? What do you think is going on?
I'm actually not sure. It was in wall following, and it should have registered that it was stuck and evaded. It could be that the bump sensor is jammed, and it's not able to evade because it's stuck.
All right, so we still have looks like a minute 30 seconds. I just noticed the what very useful debugging output that's being put up there. It certainly doesn't love walls right now, at least. So. The green eyes just for show, or those serving some special purpose?
Nope, the green eyes are just for show, and they don't mess with the color vision at all. So that's good.
All right, yeah, it is worth mentioning that we're using web cameras, which I think give about a 600 by 480 resolution. It's not great by any stretch of... Say again?
160 by 120.
160 by 120, excuse me. It's far worse than I had imagined. So you're just worried about the total amount of data that's flowing through there?
Right, we didn't want to slow down our image processing by trying to process it.
Do you want to call it?
That's really good.
Well, still a good run, so thank you very much. So you might see staff descending upon the field. It's because as strong as we make these walls, the robots always seem to be stronger. And we'd like as much as possible for the field to have the same configuration between contestants. So we actually have little pieces of black tape to mark where all of the red balls